Hello, everyone. Welcome to our session for understanding the use cases of unstructured data in healthcare. My name is Jawad Khan, and I'm Director of Knowledge Management and Data Services at Rush University Medical Center. My primary role at Rush is to store, analyze, and provide insights to the hospital or hospital system. I have about a dozen awesome data engineers and data scientists who work with my team, and that's what we do for a living, store data and analyze data for healthcare insights. I welcome you on behalf of both of my co-presenters here. Dave, you want to introduce yourself,
sure.
please?
My name is David Patterson. I'm a senior principal with Maven Wave. We're a premier partner of Google. We've been working with Jawad and his team for the past 6 to 7 months. So excited to talk to you guys today.
Hi everyone, and my name is Vasu Gupta. I am a customer engineer with Google, and I've been working with the Rush and Maven Wave team on some of the interesting use cases that we're doing at Rush. Just kind of one housekeeping item before we get started. We do have a Dory link. That's really a link on your app to allow you to submit questions anytime during the presentation. We'll have a Q&A for 10 minutes at the end, so it would be great if you can submit your questions as you're thinking about it during the presentation, or at the end, you can also come up and speak it to the mic as well.
Great, thank you.
All right.
Like I said, the idea of this session was to primarily share with all of you what do we do with unstructured data in relation specifically to the EHR, the electronic health records, how much unstructured data we collect, and what do we do with the unstructured data, how do we store the unstructured data, how do we retrieve the unstructured data, and what type of analysis we do provide. That was the idea of this session. But before we get there, let me share a few things about Rush University Medical Center. We are a very historical institute in Chicago. Anybody from Chicago in the crowd here?
Okay.
There you go. So a few folks here, you all may know about Rush. We have 3 hospitals, one out in Copley, one in Rush Oak Park, and one right in West Side of downtown. We have more than 30 plus outpatient clinics. We are a Rush University for medical school. We are a 4-time actually magnet nursing school. All you need to know about Rush is available on the website. You can go find out more. But this slide actually talks about what Rush is doing and how we are at the forefront of making an effort at least to transform healthcare. Rush was, since our CIO, Dr. Shafiq Rab, joined us 2 years ago, we were the first institution to implement a full closed cycle social determinants of health. We are very engaged with the community where we are today, and we have a system where now people coming into our center are screened for social determinants. We refer them electronically to a source, and the data flows back into the EMR. So first institution that did a full life cycle of social determinants of health. Rush is, like I said, we are first institution to implement managing meds through a mobile application, nurse documentation. We were the first institution to receive, or one of the 3 institutions to receive a stage 7 in analytics, and so it's a pretty busy slide. But the idea was essentially to show what we're doing, like I said, to transform healthcare. Even an institution like us, having said that, continuously is struggling with what do we do with the data, specifically with the unstructured data. And is anybody in the audience here who works in the healthcare, specifically healthcare vertical? There are a few people. Oh, there are quite a few people. Great.
That's good.
How many of you are like in the provider space, in the hospital space? Got it. Beautiful. So there are a few. If you look under the hood of what's in a hospital system, or specifically behind an electronic health record, it is this. It's thousands of tables, a lot of data, mostly highly normalized, very hard to find any one-to-one relationships. And then when you compound that with a problem like this where there is data everywhere else. In fact, only about, I would say, 20-30% of the data that we analyze and store comes from the electronic health record, but data is everywhere else. It's outside the EMRs, in our ERP systems, in our networking systems. And believe it or not, all the data is still relevant to healthcare. It is still relevant to how we provide care to our patients. So we are very interested in putting the data together, putting the data in a common platform, and trying to solve healthcare problems with the data. In short, healthcare data is classic big data. It comes from all different angles. It has veracity, it has velocity, and you name it. So what are we doing with it? Specifically, like I said, the idea of this presentation was to talk about unstructured data. And what are we doing with unstructured data? As you may know, because people specifically who are in healthcare and people who are specifically working in the hospital field, you may know that out of box, we don't necessarily have solutions to easily analyze healthcare data. EHR doesn't come with an NLP, so to say, right? We would have to implement that. We would have to extract the data. We would have to manage the data and implement a solution that does analyze unstructured data. Doctors like to type notes. In a typical EHR implementation, there are more than 100 plus notes. There are progress notes, there are pathology notes, there are nurses notes, there are notes everywhere. In fact, even in a most simple statement, like a nurse would be typing and saying, there's this person, oh, I receive a drug, like I'm saying there, Sally's getting drug from a friend. When you get that medication ontology and you understand what those drugs are and how do they line up to the patient's problems, it's a very difficult problem to solve because those insights are not readily available. So what do we do with unstructured data to be able to solve problem? What are we doing today? And it is, like I said, it is not really necessarily easy. And any solution that you read about unstructured data or NLP having done on healthcare is mostly still today living on the research side. Not very many implementations or not very many solutions or products have come on the commercial side. And that's what Rush, specifically our team, is focused on doing. I have some folks from my team here who have been living and breathing NLP and unstructured data for the last 2 years. Guys, you want to raise your hands, please? Accolades to them. These are amazing engineers. They have learned so much about medical ontologies, so much about how to understand what those ontologies are and how they relate to solving medical problems. Is incredible. I encourage all of you to talk to them. I'm just one person representing all the work that we have done over 2 years with NLP data. So in short, it is very difficult to extract the data. It is very difficult to store the data in a comprehensive solution and be able to provide solution. It is very, very costly, in fact. Like I said, we have spent good 2 years to extract the data from an EMR, store it in a format that we can understand in a single platform and be able to analyze it. What does the data look like today? An average provider node, specifically if you look at it, is about 45 kilobytes. And we collect about 8.5 million notes per year. If you do 2 years, when we started the project, why am I saying 2 years here is because when we started this NLP project in our institution first, our focus was to look at least 2 years worth of notes, right? Historically, go back and extract 2 years worth of data and analyze it and see what insights we can find. And sure enough, just those 2 years worth of notes were so big that our data centers couldn't handle it, or we were not able to store it and process it in a single infrastructure. So we had to look at other solutions to be able to do that. And now, because what we achieved with finding insights, and I'm going to talk about that in a few minutes, with 2 years worth of data, the institution has asked us now to expand that search, go back to extracting 10 years worth of data. And that literally will end up in petabytes of data. It's really a problem to solve. How do we actually analyze all the data and be able to provide meaningful insights for the institution? The use cases that we specifically started with unstructured data is around adenoma. As adenoma detection is a very important measure. It's a CMS measure. It gives our GI department if the doctors, for example, if patients come in and they're not screening the patients properly in colonoscopies for colon cancer, it's a big deal. It's a measure that gets measured by the CMS, like I said. So we started doing our NLP with adenoma detection, meaning we're extracting all the pathology and the provider notes to be able to identify where the doctors were typing for adenomas. And we're able to provide a dashboard straight off of the data for them to be able to see. We were successful in providing a use case for adenoma where now providers are actively using a dashboard off of our unstructured data in real time, in memory, to be able to make decisions about which patients to be called back into the healthcare or into the clinical pathway to prevent people from getting colon cancer. So this is a big deal. It is a big deal both from regulatory point of view for the institution to be compliant of a specific measure, it's a big deal for patients, right? Because we are in the business of providing best healthcare for our patients. The second was about HNP, history and physical for the providers. History and physical is also a regulatory measure. So if, to be specific about, so to explain what it means for people who may not know is, if I am going in a surgery, for example, and if my history and physical is not complete in my EHR, 48 hours prior to the surgery, that surgery needs to be canceled. If any institution fails to do that, then it's a bad mark on you. You can get audited, and it would be exception for institution. So we cannot make that happen. And for an institution of our size with 3 different hospitals, making sure every surgery has every history and physical completed manually is a big deal. It actually required a staff of 3 nurses to go through all the history and physical to make sure it's complete. Well, we were able to use our NLP engine, our AI platform, to be able to comprehensively identify and score history and physicals which were complete and which were not complete. And the guy who did this here is Darpan Amin. I mean, Darpan was instrumental in figuring out an AI solution, full end-to-end, where we extract the histories and physicals from our EMR, we run it through our NLP, and we make sure that the history and physical is complete before we provide, again, dashboard to the end users to be able to recall either history or physical or completed before the provider. So it's a huge use case, amazingly valuable for the institution. We were able to save time, money, and resources for the institution. And the third one, last but not the least, is clinical documentation improvement. Like I was giving an example of where very mundane notes can be typed about medication, about health conditions, about comorbidities. They're not readily available unless somebody is able to go through those notes and extract those insights. Clinical documentation improvement is very important. One, to make sure that the patients, we are able to provide better healthcare, proper healthcare, relevant healthcare to the patients. And at the same time, again, it helps the institution to affect and address the bottom line. That is, if you are in the payer space, you know what I'm talking about. If you're in the insurance space, you know what I'm talking about. If we send a claim to the patient for the patient's record or the transaction without proper documentation, then guess what? It gets denied, it gets rejected, it gets delayed. So it is extremely important for us to be able to make sure that the clinical documentation improvement is in place. And in short of having everything completed manually, we developed a solution that is 100% based on data extraction, unstructured data, to improve our clinical documentation improvement. All the use cases that I talked about obviously requires both processing the data in the back end, running through an NLP engine, matching with medical ontologies, sometimes general ontologies, sometimes very specific to specific service lines, be it cancer, be it hip and joint, whatnot. And on top of that, we have to make sure that we're able to provide the solutions to the end users to be able to consume the information that the engine has provided, right? Without that, it becomes very difficult. And all this are definitely important problems, but they're very hard problems. We often run into people, vendors, who talk about having one solution in one place, and to this day, we haven't found it. It's very, very difficult. You always have to put pieces together to be able to solve the problem with unstructured data. And anybody who's familiar with working with file system databases and extracting the data in the native format, storing it, it's a challenge. And if I'm doing it on daily basis to operationalize something, it's a challenge. These problems are definitely not easy to solve, but they're very, very important. And if anybody, in my opinion, is not dealing with unstructured data that is available in the institution, in any healthcare institution, then we are not looking at one of the key components of the data that we need to analyze. So that's the story that you need to take away from today is that if you are not, as an institution, if you're not tackling unstructured data, then you're leaving a big piece of puzzle behind. It is very, very important that institutions like ours, who are primarily responsible for providing best healthcare, should 100% look to solve unstructured data. Analyze it, solve it, and provide it as a solution for the institutions. Having said that, the challenges are unlimited. There is many more use cases that can be done. Even today, after what we have done for past 2 years, we still have disjoint data sets. There is unstructured data, like I said, in our ERPs that need to be brought back, that will be consumed. There are all types of solutions, and we are slowly and definitely working towards solving those problems. This slide specifically was to help you understand what it is and show you how we have achieved some of those use cases. What we wanted to do, what we have learned it definitely, to be able to solve or put together a solution using unstructured data, we have to make sure that we're able to solve the problem, one, by collaboration internally and externally with the partners and the people within the resources. We have to make sure that we are able to, like I said, provide notes to the end users that is intuitive for them to be able to consume the data and be able to work with the data that we have provided and the insights. How do they do interventions with the data that we are providing? What actions are able to take, they are able to take with the data we are providing? These things are definitely not, or cannot be isolated or siloed. You have to put that together as you're thinking through these problems. The second is scale. How do we scale this problem? How do we, like I was saying, go from 2 years to 10 years? And how do we do it in a cost-effective fashion, right? And single source of truth. This continues to be a problem. We have tried so many different solutions. And I can speak to you very transparently that when we first started on this journey 2 years ago, 4 or 5 months within the project, we failed. We miserably failed because we were not able to properly implement a solution that was cost-effective. The cost that we were incurring for storing and processing the data was growing significantly. There was a question about why not do it in-house as opposed to do it in cloud. There were so many different problems that we had to solve. So it's definitely worth trying something, failing early, and fixing it as you go about. That's the lesson that we learned and I wanted to share with you. What now? So what do we do? Like I said, we want to go into the space of pop health. We want to be able to do a lot of KPI performance improvement using this data. We have a lot of novel cases that we want to implement as we move forward. Maybe this is time for us to talk about how we are partnering with Google and Maven Wave to sort of solve this problem. Like I said, unstructured data obviously is very important to solve, but it is not you cannot solve that before actually also marrying that with the structured data. And how we are using or leveraging GCP today, I think Vasu will talk about that. Vasu, please.
Yep.
Yes.
All right. Thanks, Jawad. So Jawad hit on kind of the business problem that we were really looking at Rush, and really kind of this unique problem of melding the unstructured data with structured data. What I'm going to talk a little bit about is really how Google Cloud Healthcare and the products and solutions that we offer was instrumental in making this kind of business problem and solving this business problem. And really the focus of my part of the presentation will really be on the Cloud Healthcare API and the Clinical Data Warehouse, which were two of the unique products that were critical and integral to really building out this end-to-end pipeline for solving the business problem. And Cloud Healthcare API being that key mechanism for ingesting and storing and analyzing of the data, and then Clinical Data Warehouse, as you look at different sources and all these disparate data formats coming together, how you really kind of put that together and really build this notion of a clinical data warehouse sitting on top of something like BigQuery for the petabytes amount of data that you're looking to handle. So what is the Cloud Healthcare API? So it's a solution that's being built by the Cloud Healthcare team that really understands, talks the healthcare-specific vernacular and healthcare-specific language. It's really meant to accelerate your ingestion of your data, your storage of the data, the analysis of the data specific to healthcare. In its current state right now, it supports DICOM, HL7v2, and FHIR, which stands for Fast Healthcare Interoperability Resources. And there's so many people in the crowd that are from the healthcare industry, this should not be a surprise. And if you look at sort of the trend within the healthcare industry and the fact that there's so many disparate data formats, there's kind of a move in the industry in healthcare to really standardize to adopting FHIR as that gold standard. But like I said, the healthcare API supports all these different 3 data types in its native form within the healthcare API. What does the healthcare API comprise of in a nutshell? So really, I kind of boil it down to 3 main components. At the center of it all is really a secure, high-performant repository that exists for DICOM, HL7v2, and FHIR. So there's a FHIR store, an HL7v2 store, and a DICOM store that exists within the healthcare API. And then wrapped around that repositories is a series of both admin and access APIs that are compliant with healthcare data standards and really allow you to talk that healthcare-specific language and access that data that's sitting in those stores. And then third is really a suite of integrations and capability that allow you to do the most with your healthcare data. So a combination of the repositories, the APIs, and the integrations, whether it be integrations to your systems that is ingesting the data or integrations outside to external applications to send the data out. Healthcare API provides those capabilities, and that's why it's a unique and compelling product, and also why it was critical in kind of solving this problem of ingesting this unstructured data, which in this case for Rush was within FHIR messages that we ingested from the different EMR systems. So if you kind of look at the clinical data mapping workflow in its kind of entirety, the data, like I said, it could be in different formats. It can be in HL7v2, FHIR. It can also be in some of the other non-standard formats like CSV, XML, so on and so forth. So as you're looking to ingest these data across from different systems and different formats, and really trying to build this sort of central place in storing that data, you kind of go to the healthcare API. And like I said, there's a FHIR store within the healthcare API that allows you to capture that data. But there's like a middle transformation layer, right? So you've got all these different sources, and especially if you're looking at doing cross-modality analysis across the different data sources, that transformation layer, to convert HL7 to FHIR or CSV to FHIR, really allowing that and capturing that data in something like a FHIR store is that's something that Cloud Healthcare API does really well. And then once that data is there in the Cloud Healthcare API in that FHIR store, the data can be exposed to external applications. So an example could be an application sitting on top of App Engine, or even the data could be exposed as APIs through something like Apigee and so on and so forth. So that data, again, can be exposed to external applications. And then also, if you're looking at, again, melding that unstructured and structured data, if you want that structured analysis of that data, in this case, we had notes that we were ingesting as FHIR messages, and we wanted to create a schema that was standard for analysis. The data can also be stored in something like BigQuery, or even if you want to do machine learning models on top of the data, then really using a product like Cloud ML Engine to do some of that machine learning. So all in all, if you kind of look at that end-to-end workflow from the ingestion to the standardization to really exposing the data in different ways, that's something that we built as the common architecture pattern when we were working with Rush. One of the other capabilities that the healthcare API provides is the ability to react to data near real time. And what I mean by that is there's a strong integration between the Cloud Healthcare API and Cloud PubSub, which is our real-time messaging and event streaming service. And anytime a data lands in the FHIR store or the DICOM store, it essentially sends a notification message to PubSub, and that could be a trigger for different things that you do downstream. Again, whether it be certain rendering to certain applications, or maybe a cloud functions routine that in turn, executes a machine learning model, the output of which can then be integrated back into your external application. So this kind of powerful notion of being able to react to data real time, to think about real-time inferences as you start building your machine learning models is a really compelling story with the healthcare API. Another capability that is provided is the ability to de-identify your FHIR and DICOM resources. So within the Cloud Healthcare API, there's a de-identify call that you can make, and depending on the attributes that you specify, you can configure that, and it will de-identify those specific attributes and create essentially another version of your data set or store and capture that within another FHIR store, or DICOM store, and so on and so forth. And this is applicable, again, even on the DICOM images, the FHIR resources, and so on and so forth. And then last but not least, another key capability is the ability to export this FHIR and DICOM metadata to BigQuery. So again, coming back to Jawad's point, this notion of really being able to analyze this unstructured data and make sense of it, and capturing it in something like BigQuery can be extremely powerful. One of the things that's not on here, but that's something that's being released really soon, is Cloud Healthcare API is also going to be able to support real-time streaming of data to BigQuery. So that's also coming. So in the future, essentially as the data is coming to Healthcare API, without this export call, the data can be streamed into BigQuery directly. So again, in summary, this Cloud Healthcare API was central and core to building this pipeline and ingesting these these unstructured data in the clinical notes embedded in the FHIR messages for our solution. But kind of shifting gears a little bit and talking more on the structured data side, again, if you think about this, going back to this idea that you have data coming from different sources in different formats, both historical data and incremental data, you want to map it to some sort of a common data model, right? There's a lot of different data models that exist within the healthcare industry. So thinking about kind of your OMOP data model, CDISC, or even a consistent and structured FHIR schema, that again is that middle layer, the mapping and transformation layer that becomes critical. So how do I map HL7 to FHIR, or how do I map CSV to FHIR? So one of the other products that the Google Health team is investing heavily in is really building this mapping and transformation layer to make this clinical data warehouse solution really effective and really efficient. And the idea behind that is going to be building of a mapping and a configuration tool that allows you to map between different data formats and provides you this UI and GUI-like interface to allow you to map between different formats. And we're interjecting that layer with a lot of machine learning capabilities. So how does that mapping layer become smarter over time as you look to transform and build these target schemas and build this notion of a clinical data warehouse on BigQuery? And kind of taking it one level further, if you think about what you really want to do from, you've got all these different sources, you've got all these different types of data, how do I really do cross-modality analysis? How do I blend, for instance, maybe genomics data in the future to the data that's coming from FHIR, HL7, DICOM, so on and so forth. So if, again, thinking about the pipeline, ingesting the data from EHR systems or your PACS systems into the healthcare AI-specific stores, capturing that data in BigQuery, performing certain transforms and different analytics on it, and really creating these ready-to-consume schemas, which could be, again, OMOPs, custom-made schemas, FHIR schemas, so on and so forth, and having it to the end user for different analytics and visualization use cases is really our kind of vision for this cross-modality analysis and really this ability to build this clinical data warehouse in BigQuery. So I'll just wrap up by saying that, again, Cloud Healthcare API and the Clinical Data Warehouse were key healthcare products and solutions that we kind of considered as we were building this architecture. And I'm going to hand it over to Dave, who's going to talk about the end-to-end solution architecture.
Thank you, Vasu. All right, so I get to hopefully bring some of the solution together.
Yeah.
And link the healthcare API back to the message and challenges that we were having at Rush. So what I want to show you is how we can combine the healthcare API along with a natural language processing engine running on GCP to unlock key healthcare use cases that Jawad referred to. That includes document integrity checking, clinical decision support, public health records, and disease trends. Before I get to the solution, I wanted to give you or share with you the journey that Maven Wave and Rush has been on. When Maven Wave works with clients, we typically recommend 4 phases for moving workloads to GCP. The first one is assess. So this is when you're prototyping, you're experimenting, and really trying to figure out if GCP is the right fit for your solution. The second is planning. This is setting up infrastructure, getting projects organized, setting up billing, and most importantly, picking your first workload. Moving on to deployment, this is implementation, migration of the workload, and finally operationalizing, which is standing up a program with your kind of future work backlog. Key throughout this process is to tightly align scope to business value and security needs rather than trying to build the perfect technology platform, really kind of quickly deliver business value to kind of build credibility in the organization. So where we're at with Rush, we are through the first deployment and working with them to define future workloads that Jawad will talk through here in a little bit. All right, so let's get on to document coding basis. So back to what Jawad was referring to in terms of kind of getting structure out of unstructured patient documents. So what are the basic building blocks? The first one is applying core NLP. And this is kind of the standard technologies that are used across natural language technologies. But that includes parts of speech extraction, context, negation detection, and most importantly, for this use case is the named entity recognition. That's a challenge in medical or clinical notes, which makes the second step critical, which is applying medical vocabularies. And these are vocabularies that are curated by international health organizations. The two that we used in this solution was SNOMED CT. That includes 300,000 coded medical concepts, including diagnoses, clinical findings, body structures, and observations. The second is RX Norm, which is geared towards pharmaceuticals and links to common drug vocabularies. So the third building block is taking our coded documents and, like Vasu was mentioning, getting them stored in a clinical data warehouse. So let's look at an example of what this looks like. Here you can see the precise codings that have been extracted from a fragment of a clinical narrative. And it's these precise codings that really form the foundation for cross-patient analytics.
Audience are 100% engaged.
All right, so in terms of our solution approach, first we wanted to land raw unstructured patient data in the healthcare firestore. So we didn't use a great amount of the data structures available in the API, but we did get a lot of acceleration just from using and not having to redefine a schema as we're moving raw data from the EMR into Google. Second were the security controls that were already in place. Second step was establish an auto-scaling medical NLP microservice platform. We did that on Kubernetes engine. Third was leveraging data flow and Beam pipelines for data orchestration. And then finally, creating a clinical data warehouse in BigQuery. So establishing the NLP core. Fortunately, there's been a lot of good work, I think Jawad mentioned, in the research hospitals, research organizations around this problem set. So we were able to use two open source technologies, CTAKES and QuickUMLS, and then augment that with some custom rule-based NLP for Rush. The bad news is that some of these technologies have evolved over the course of a decade or more. So, they're monolithic. They had varied support for APIs. So the second step was to modernize and normalize those applications. So we performed some optimizations in threading and around performance, and then we implemented web-friendly APIs in JSON and gRPC. Finally, containerizing and then moving to Kubernetes engine. And this was key to kind of providing that kind of auto-scaling capability and cost control that Rush was looking for. So putting it all together, so working from the left, we sourced unstructured patient records from the EMR. We landed them in the healthcare API. We leveraged some of the event triggering that Vasu mentioned to trigger real-time data flows to then apply the NLP coding, and finally storing that in a scalable data warehouse built on BigQuery. And that sets us up nicely for future ML workloads as well as descriptive analytics and data exploration. Some future workloads, we plan to take imaging data from the PAC system, DICOM files, and move them to the healthcare API. Claims data and ERP also to kind of round out operations and kind of do cross analytics with that patient data. Here's a different view of the same architecture. We can see EMR, some of the future data sources at Rush, patient data storage in Fire, filtering and parsing in data flow. We got a medical NLP on Kubernetes engine, finally moving that into a clinical data warehouse on BigQuery. All right, I think I'm going to hand it back over to Jawad for some takeaways and roadmap items.
Thank you, Dave. So, like Vasu and Dave mentioned, we started with just looking at unstructured data, meaning we were specifically focusing on just the notes that we were extracting, but there are several modalities that we are now starting to work on because we have confidence the architecture seems to be pretty stable, and I think we're ready to expand to other modalities. And the first one that we're going to look at is, like Dave talked about, is to connect our PAC server to the GCP environment and be able to directly query the data from the PAC server into a DICOM store and then have machine learning models run on that imaging. The second use case is to do very similar to PAC server, but more focused on the cancer side to actually do some mammograms. And there is a solution already out there that we use today, which is on-prem, to do a real-time AI on a mammogram. So if somebody comes in for a mammogram, the image gets into the PAC server, and we immediately run it through an ML model to sort of annotate it to see if it is positive, negative for breast cancer, right? Those cases are running today, on-prem today, but it's very isolated to just mammograms, but we are expanding it to other imaging solutions. And the idea is to be able to do that over the cloud, because obviously it would have to scale for other use cases. The third is our clinical data model today is completely in our data centers, in our on-prem data centers. Both the transactional or operational databases, the data warehouses are all within our data centers today, and our unstructured or advanced analytics all happening in cloud. So there is a sort of a disconnect. Every time we have to bring clinical data to be able to correlate with our advanced analytics solutions, we are having to either batch these queries back into the cloud or bring some of the unstructured data that we have now converted into structured data down into where the warehouses are and be able to do analytics. But ideally, I think the time is right for us to be able to look at those data structures and data warehousing solutions very carefully now, and we are seriously giving it a very hard look to see if we can implement a common clinical data model that supports both advanced analytics and our BI solutions in cloud type of structure. There are not many very well-designed clinical data models that are out there. I don't know if you guys are familiar with OMOP. We use OMOP as a data model for some of the use cases, but it doesn't necessarily support outside of just transactions, right? So we have other clinical use cases that we want to expand the data models to. And we really want a true representation of a clinical data model looks like, including the patient finances, including corporate finances, and including our clinical outcomes. We are very closely looking at, like I said, to move that into our GCP or BigQuery type of environment to be able to leverage both structured and unstructured data. Last but not the least, it is of high interest. I mean, it's one of the institutional priorities to be able to develop a search solution. Today, it is very difficult to search within the EHRs, electronic health records. You can probably do a search even with a third-party solution across the patient charts. Maybe just looking at the patient chart vertically, you're able to search for comorbidities and some of the diseases that you're looking for specifically. But doing across the EMR is a bit not there yet, so the provider is not able to look his or her empanelment in a very comprehensive way to be able to identify solutions. And then to make it more complex, what if you have more than one EHR? How are you then able to search across all the EHRs if the provider is seeing a patient, say for example at our satellite location in a different EHR, and the provider now comes back to the hospital as an attendee, he has this patient here, he's not able to really search for comprehensively across all systems. So the idea is to again bring all this data together in a common clinical data model, have unstructured data insights available in a single place where we can do searches. We have a name for it. We're calling a single BigQuery that we want to implement as part of the EHR solution.